years. His interests are in secure programming, cryptography, open source and firewalling techniques. For the last few years, he has been breaking mostly bank and telecom web applications in the Asia-Pacific region, as well as performing penetration tests for them. Originally from France, Fabrice has been staying in Singapore for the last 5 years. So ladies and gentlemen, do join me in welcoming Mr. Fabrice M, hacking internet banking applications.
Good afternoon. First, I would like to apologize for being sitting. I will not speak very loud. I fell sick just before coming here. So the goal of this presentation, basically, there's nothing technical. I believe there's loads of good presentation on how to perform properly web attacks. So instead, what I'll show you is I will just demystify a little bit what's behind internet banking, and I'll show you just how simple it is to perform an attack. And this presentation is also focusing on how to actually conduct proper procurements for internet application. You get taken advantage of every single time and you ask for more, so I'll show you how to avoid that. So what we're going to talk about are basically the usual attacks. I won't spend so much time on that. I will look at two kinds of attack, the read attack and the write attack, which will be the frauds, and mostly procurements and real-life statistics based on the last few applications we've audited. So all this is based on live results. All this has been out there. So, I'll be quick on the banking architecture. It's always the same. There's always a three-tier architecture. It's always been done properly. The bank understands this for a long time. They always put firewall at each every layer. They put redundancy. They spend generally a lot of money on hardware and software for that. Some of the better ones even have reverse proxies. But all in all, it's mostly done properly. Technologies, you basically have two. You have Java. The advantage of Java, I would say, is that it runs pretty much everywhere. Unfortunately, all those application servers have their own better feature and so on. And in fact, well, those beta features, of course, are not portable across application servers. So in the end, your J2A application is supposed to run everywhere, but it won't. Another thing for bank is that we don't really care if it runs everywhere, because what you have to remember for banking technology is that the application does almost nothing by itself. It's mostly the interconnection with the bank host. It's the integration part of the bank application that is the biggest. The part that do all the business logic, which is fund transfer and all that, this is very, very, very small. .NET, so .NET, the advantage is that you run on one single platform. The only problem I personally have with .NET is that they allow programmers who should be shot to actually code just by clicking on buttons, and it works. Microsoft did a good job for that, is that it works. But the problem is that when you do not understand what you are doing, you will end up doing stuff you're not supposed to do, and of course we'll find it, and of course we'll hammer you with this. So the framework is a good framework. The problem is that people point and click without knowing what they're doing. So eventually, yeah, it won't work. We have Mono on the rest of the platform I mean, if your application run on .NET, but it's not mature yet. I would never run banking stuff on Mono. So the funny part now, what is usually good within a bank, within a bank network to support the application? Usually, like I said, the network, system architecture, all that, banks understand this. There's plenty of guys out there who know how to do it, so the bank just put money on the table, get the guys to do it, and it's done properly. Session management is the single one on which all the banks spend all their money. They will come up with fancy authentication. All of them have a different one. Some of them have tokens, some have two-way authentication. They have all sorts of authentication. I'll show you later why this is all useless. Authentication will be useless in a minute. I'll show you why. It's very simple. In Singapore, we have password encryption from end to end, meaning from the client to the authentication box. So in other words, it means the bank never ever has your password. It's all in the black box. And of course, good quality trail, I need to explain a bit more. There is good accountability, good audit trails only for those successful and unsuccessful normal transactions. As in transaction that you haven't messed around, you just use the application. Succeed, succeed, fail, fail. Not something that you try to mess around with. When you try to mess around with it, we'll see later, there is no logs whatsoever, which is perfect for hackers. And well, I'm sorry, but that's all. All the rest is crap. Everything else. I will say in a minute just what is crap. Okay, what's usually not good? I want to apologize to any developers out there, because that's for you, this one. I'm sorry. I am a developer myself, so you know, some of this applied to me in the past and whatnot. That's probably also why I'm not a developer anymore. I don't like when people laugh at me for no reason. So yeah, programmers, I'll start by the bottom. Programmers, you are lazy. You really are lazy. I don't want to point fingers, but it's true. Well, I was as well. You're forced by your boss to use frameworks that are fantastic, do all sorts of things for you, but those frameworks don't adapt well to what is it that you have to do. Sometimes it's faster just to rewrite it. Don't be lazy. For developers out there, they will understand when I say this, you use the wrong hammer for the wrong thing. In whatever your job is, you always have a hammer. You always have 2 to 3 ways of doing it, and you have one favorite way of doing it. Now, regardless whether it's a good way to do it or not, you will use that way. So for programmers out there, you will use a tokenizer or regex, and you will use one and always use that one. Sometimes it's better to use one, sometimes it's better to use the other. And of course, people never log any errors, never ever. Bad quality code, that speaks for themselves. Be nasty with it, you're just going to die. And lack of input validation is basically the single biggest problem that happens with web applications in general. The thing is that on a lot of applications, it's pretty tough to do input validation. I mean, you depending on what parameter is it that you want to validate. In banking, it's very simple. We only validate numbers. We only care about numbers. Numbers, emails, and maybe 3 different types of data like this. So don't tell me you can't input validate these. There's nothing to be done. You do a library once, you keep on reusing it, and you're in business. So that's usually very bad, and there is a lot more than that. Those are things that I've seen in real life as well. It's not funny. I mean, it's funny without being funny. I'm being serious. I've seen that kind of stuff. There's a lot of stupid people out there. They believe that a hidden field is hidden. Bravo to all those who believed that it was. It's not, in case you don't know. Anybody can say it. They believe the drop-down button, you can only select what you see. So again, we don't use your browser, so you know, we can change pretty much whatever we want. They also believe that what's not in the menu cannot be run. That is fantastic concept as well. Yeah, they forget that everything runs on the server, on the clients. We just instruct the server to do it. So all we have to do is ask the server to do it, and it will get done. So for those who don't know what's a cookie, don't worry, it's nothing to be eaten. But for those who know, it's an input like any other. And it is an input like any other. There are countless programmers who believe that cookies are something magic that you can't touch. You can't mess with cookie, can you? Of course we can, it's just an input like any other. And my absolute favorite about idiots of programmers who believe that hexadecimal or base64 or any other encoding is some form of encryption. So to those idiot programmers, I would say get a dictionary. The dictionary is very clear that encryption needs a key to encrypt or decrypt, for that matter. If you do encryption without a single key, that's called encoding, because any idiot can decode it. No matter how fancy is your encoding, as long as we know what you're using, and you're going to be using the same 4 usual stuff, hexadecimal, base64, you encode, we just look at it, we know it already. It's always the same, you know. So don't try to outsmart us with some encoding. Try encryption on the other hand. It's the same function call. I mean, it's just one function call as well, but it's just you give a key, one more parameter. Don't be lazy. And of course, there's a lot more, but those are like the top 5, 6 most stupid things that I've seen in web application. We should do a competition one of these days of the most stupid programmers. I tell you, there are some of them should be shot, really. So what do we need for a successful attack? And then probably you will stop laughing in a while. Is that we don't need much to do an attack. Like I said, I don't really care about your authentication. It can be the most secure, it can be biometrics, it can be whatever you want. I'm gonna open an account with your bank, and you will welcome me open arms. I'll just deposit 5 grand on my account. You'll be happy to get me as a customer, you know. I mean, you see, I dress nice, you know. You wouldn't know. And so, sure enough, you're gonna give me a username and a password because I am a customer and I need to access my money. And well, this is another thing. Sometimes there is a smart card end-to-end encryption. They use crypto smart cards. This will just make it a little bit harder for us to break, in the sense that we'll have to modify some of our tools to work with this. It's still possible. It's just you're just slowing us down a bit. And that's all I need. So you see, anybody can start doing that kind of stuff. All I have to do is to open an account with your bank. Shouldn't take too long. I don't know how long it is in Malaysia, but it should be about the same as Singapore. Just come with your passport and the cash, and well, they ask you lots of questions, and you're out, and that's it. It is possible without this, of course, but the attack won't be so interesting anymore. Right now, we're going to use the application to perform all our attacks. We don't even have to understand how does it work behind the hood. I don't know anything about finance. I don't have to. It doesn't, I mean, I just ask the application to give me the money and it does. So, you know, that's all I care for. So without this, it's still possible. It's just slightly harder. So remember, your authentication, no matter how fancy it is, I don't care. I just don't care. It's good to have some, because otherwise anybody can log on to the application and anybody can do what we're going to do later. Right now, you're limited to your customers, more or less. Having said that, though, you think that since it's your customer, you'll be able to bust him once he steals money from you, but you won't. Because I said earlier on, the audit trails are extremely bad when hacking is happening. So eventually you still won't catch the guy. What do we use? Well, we don't use anything fancy. It's really just pure basic. A lot of bankers, when they are behind us, they expect to see swordfish kind of stuff. You know, nice 3D graphics moving around, whatnot. No. When you hack the bank, it's just a proxy and it looks boring. It is boring. I will try to make it slightly less boring. We use a lot of decompilers. A lot of vendors hate us for that. They are our personal favorite. We found one very nice, for example, in the backend, an authorization function, which read the body of the authorization function was returned true. So it means you're always authorized. So that's pretty handy as well. They hate it when you decompile that kind of stuff because you show the stupidity right away. You just show where is the mistake. We use encoders and decoders. Remember, this is not force. You can brute force all you want because there is no error logging whatsoever. So and when there is an error logging, sometimes it's just all the exceptions that are put into a flat file. So at the end of the day, when you have 2 million exceptions in a flat file, good luck with your forensics. Just good luck. I'll be gone a long time ago with all your money. Banking messages are those small messages, you know, when you do a transaction, he will tell you, oh, your telegraphic transfer failed, or it succeeded, or you didn't have enough money last minute to transform it. All sorts of little basic information, but that could be quite interesting. So it's also possible to read other people's banking messages. This one is extremely straightforward, all the implementation we've seen, because every time they use an incremented message ID. So you can read everybody's message, just increment one by one and ask for the next message, next message, next message. If you get a message that doesn't exist, it means you reach the last message in the database. So it's extremely quick. You start with message 1 and go all the way up. That's a personal favorite as well. It's always nice to know what your boss spends on, or what your prime minister what spends on. It depends if you're into politics or not. I'm not, so I'm more interested in what the boss spends on. You have to have the card, the number most of the time, but don't go and think that, oh, it's safe, you know, card number, nobody knows it. Bollocks. Everybody got the card number of everybody. It's not difficult. All I have to do is to go for a beer with you. You're gonna buy me a beer, and I will see your card number. You know, it's only 4 times 4 digits. I think I can remember that. And you know, that's all I need. This and your name, and maybe the CCV code behind, and that's it. For the bank application, I don't need the CCV code. I don't need your name. I just need the credit card number. And I need, of course, to make sure that you are inside this particular bank. But guess what? The credit card always have a fancy logo of the bank. At least on mine there is. So it's obvious to know which bank I'm in. So eventually you get very detailed credit card bills of the guy, and that's really nice. This is you can have quite a good fun with this. By the way, for those decision makers out there, if you have a chance to make a decision like this, if you could please find something else than credit card, because that's the worst way payment method ever. I mean, there's never been any security on it, and there never will. It's just impossible. It's just a number. How do you want to secure a number? So if some of you are in meetings of very high power people into banks, to come up with new standards and stuff, please do something for that credit card. We want to get rid of it. We really want. So how do you protect against read logic flows? Well, it's very straightforward. Again, this is all simple, but you're not doing it. You're not doing it. As simple as this. All you have to do is you keep as many parameters as you can on your server. Why do you want to pass all and each and every small parameter to the client? First, it's going to be slower because the parameters go back and forth. Second, you give a chance to the hacker to play with it. You give him a grip, basically. Pass them by reference instead of passing them by value. Like this, if I modify the reference, it will be an invalid reference, and that's it, and I can't modify it, and I will be screwed. And of course, you verify that it's authorized. You do verify from each and every transaction. Okay? It's not being done. I know it sounds simple. It is simple, but it's boring. That's why I'm not doing development anymore. What do you think? It's boring development, I know, but it's got to be done. So now the interesting attack. I mean, interesting. Everybody wants to steal money. So that's the way you do it now, is with those write logic flows. Write logic flows is exactly the opposite. We don't read, we write. So write in that sense will be whatever that leaves a trace. So a transaction is a write. When I modify your personal information, whatever I do that leaves a trace, that modifies something, it's going to be a write. Again, applications are stupid. They just do what they are told. So you just told them to perform the fraud for you. And again, supposedly it will check, but it won't. It just never does. And what it does, it never does properly. So we'll still find the flow and we'll still bang on it. So of course, this one everybody has tried, even some of my colleagues who are not specialized into that kind of stuff. This is definitely the prime suspect. When you see something like this, your hands are itchy and you're going to try something like that. Everybody has in the IT security industry. Instead of forwarding a message whereby the money goes from my account to my friend, I will change the from field to the victim going to my friend, or to a second of my account. So of course this is a prime suspect as far as logic flows are concerned, because that's the very nature of that functionality. What you have to remember with all those logic flows is the more features your bank application has, or any other application for that matter. This is just bank because, well, you steal money, it's nicer. But every other web application are the same, when it comes to logic flows. The more features they have, the more easy it's going to be for us to find one that we can abuse in a way or another. So this one to abuse is very straightforward. Of course, I steal money right away. But here I'm still not stealing from the bank. Imagine, I have to find a poor soul from which I will steal money. Sometimes you won't steal from the bank if you don't like the bank. So another one, cashier order. Again, I have very limited financial knowledge. Until recently, a cashier order I never received any. But we stole lots and lots of money using that on the other hand. By the way, before I continue, don't be scared. When I say we stole and so on, we're totally legal. I don't want the police to storm and everything. This is whatever we've seen when we perform application assessments before they go live. I may have forgotten to say that. So don't worry, don't go out and close your account right away with the bank. Usually they do check. If it's not checked, then now you know what you're going to find into it. But typically it is checked, and typically this is what you find. So a cashier order here, again, very simple. You just take it from, help yourself from the victim funds. Buying share at discounted price, I love that because I don't know how to buy share properly. So I don't know anything about that. And they usually do it in C, and again, they don't know how to code in C, so that's where you get your buffer overflow. Again, I was pretty quick on this, everybody know about those, they're not so, but they are still there in banks though, although they are rare. Weak script, my personal favorite. It's amazing the amount of crap you can find on bank servers these days, on application servers. You have some scripts that don't even compile. You have some that don't even check that the parameters that they need are there in the first place. You have verbose error messages. Some will crash the whole server if you just call them without parameter. And they're easy to find, you know. We don't do black box. We have 1 to 2 weeks to audit an application that the guys wrote in 3 years. We're not going to play hide and seek. We're just going to get the EAR file or the WAR file or the whole web root file, an archive and so on, and we'll have all the files inside there. All we'll do is we'll build a bunch of URLs to encompass them all and call them one by one without parameter and see how they survive. You'd be surprised that at least half of the scripts will die with a horrible error message or will crash your whole server or fancy stuff like this. So it means the developers haven't even done the most basic job, which is to check that I receive exactly what I'm expecting. So it's extremely quick to test, although it's monkey job. This gives you a pretty quick look and feel, you know, of how crappy the application is. And most of the time it's not how good, but how crappy it is. You'll see later when we see about the logic flows that you typically find in those applications. Denial of service, well, you know, if you can't steal from it, you can still trash it if you really don't like that bank. No, I have nothing against bank, huh? Don't worry. So the common one, again, I'll be quick, it's not so interesting, is part recursive operation. You're supposed to call another script, but you manage to call yourself, so you end up in an endless loop, and you will effectively kill the machine, or run out of threads or things like this. Extremely long timeout, this is in pretty much every application. You force the application to do a slightly or a lot longer than usual operation, and you do it in parallel, and then you will use up all the threads of the application server. So again, the application will be totally unresponsive to anybody else. Blocking operation, one of my favorites. Sometimes server-side scripts are stupid enough to read files that you tell them to read. In which case, I've got plenty of files that are either blocking on Windows or URL that are blocking as well. So eventually, you'll use up all the threads, and again, it will be DOS. And of course, buffer overflow. Since, like I said, all the object-oriented languages don't have buffer overflow, Java doesn't have any. So if you find one on a Java application, it means they got some C code somewhere. And the C code, the magic stuff of it is that it won't get an exception. It will just get a segmentation violation, or the equivalent signal on Windows, and it's going to crash the whole app server, which is a lot nicer. Right, now the interesting frauds, the one that, as far as banks are concerned, are interesting. For us, you will see, it's very straightforward to apply. All these I will not explain exactly in details how do we do it. I'll make it sound easier. Some of it is very easy, some of it is slightly less easy. The goal is to show you the strategy that we use to steal money. Some of it is trivial, some is slightly less. So you will see, more or less it will sound trivial, and yet it is there. Because I'll show you later with statistics just how often it is there. Right, so first we introduce a read logic flow. What's a read logic flow? It's very simple. It's when you read stuff you're not supposed to have access to. On a bank application, that'll be I don't have access to John account information. I just have access to my own. And remember, application in web-based application, they're very simple. They just perform what the web client asks them to do. So you just ask for the forbidden information, and that's it. Of course, the application is supposed to check and tell you, no, I'm sorry, you're not authorized. But it never does. It just never does. Because people just click, 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 and the application exists and works. So how would they know? So there is a few kind of, this is a slightly more technical piece of advice for web developers out there. If you ever pass all the parameters that I need for the request on the command line, I mean on either the get request or the post request. In other words, if all the parameters are in the hand of the attacker, it is almost confirmed we'll find a way to whack you. We might not walk you direct, it might take some time, we might find some weird Ulu way, but we'll find it. The goal is basically to limit the number of parameters that the client passes to the server. Because like this you limit your visibility, as in the attacker can only touch what goes between his machine and the server. So of course some of them are slightly better. They do check, you know. And in which case we're left with only a harder vulnerability, whereby we managed to modify stuff server side. There were a few flaws like this in the past, but they're pretty rare. So, in a nutshell, what we do is that on top, it's always the same on all the schematics you will see. On top is what we do on the web interface as a normal user, you know. So right here, typically, I would want to check my own transaction history. And in fact, what I do is I submit that request, catch it with my proxy, and on my proxy, I replace what you guys can see over there in red. Again, this is in plain English, this is simplified. When you see one parameter here for the application, it might be 10 of them, and some might have to be brute forced and stuff, so it's sometimes a bit harder. But like I explained earlier on, all we do is to ask for the prohibited information. Now I'm asking the transaction history of the victim. It's either the application checks and refuses, or it doesn't, which most of the time it doesn't, and it will give it to me. Spying on competitor bill payments is the same. The message is slightly bigger. Look at the message on the right mostly. Instead of looking at our own bill, which has our own bill ID, we look at the one of the victim. This one is slightly harder because typically you will have to know the bill ID, which is usually a reference on the database, and you may have to brute force that one. But again, brute force, you can brute force all you want because there is no error logging whatsoever. So and when there is an error logging, sometimes it's just all the exceptions that are put into a flat file. So at the end of the day, when you have 2 million exceptions in a flat file, good luck with your forensics. Just good luck. I'll be gone a long time ago with all your money. Banking messages are those small messages, you know, when you do a transaction, he will tell you, oh, your telegraphic transfer failed, or it succeeded, or you didn't have enough money last minute to transform it. All sorts of little basic information, but that could be quite interesting. So it's also possible to read other people's banking messages. This one is extremely straightforward, all the implementation we've seen, because every time they use an incremented message ID. So you can read everybody's message, just increment one by one and ask for the next message, next message, next message. If you get a message that doesn't exist, it means you reach the last message in the database. So it's extremely quick. You start with message 1 and go all the way up. That's a personal favorite as well. It's always nice to know what your boss spends on, or what your prime minister what spends on. Depends if you're into politics or not. I'm not, so I'm more interested in what the boss spends on. You have to have the card, the number most of the time, but don't go and think that, oh, it's safe, you know, card number, nobody knows it. Bollocks. Everybody got the card number of everybody. It's not difficult. All I have to do is to go for a beer with you. You're gonna buy me a beer, and I will see your card number. You know, it's only 4 times 4 digits. I think I can remember that. And you know, that's all I need. This and your name, and maybe the CCV code behind, and that's it. For the bank application, I don't need the CCV code. I don't need your name. I just need the credit card number. And I need, of course, to make sure that you are inside this particular bank. But guess what? The credit card always have a fancy logo of the bank. At least on mine there is. So it's obvious to know which bank I'm in. So eventually you'll get very detailed credit card bills of the guy, and that's really nice. This is you can have quite a good fun with this. By the way, for those decision makers out there, if you have a chance to make a decision like this, if you could please find something else than credit card, because that's the worst payment method ever. I mean, there's never been any security on it, and there never will. It's just impossible. It's just a number. How do you want to secure a number? So if some of you are in meetings of very high power people into banks, to come up with new standards and stuff, please do something for that credit card. We want to get rid of it. We really want. So how do you protect against read logic flows? Well, it's very straightforward. Again, this is all simple, but you're not doing it. You're not doing it. As simple as this. All you have to do is you keep as many parameters as you can on your server. Why do you want to pass all and each and every small parameter to the client? First, it's going to be slower because the parameters go back and forth. Second, you give a chance to the hacker to play with it. You give him a grip, basically. Pass them by reference instead of passing them by value. Like this, if I modify the reference, it will be an invalid reference, and that's it, and I can't modify it, and I will be screwed. And of course, you verify that it's authorized. You do verify from each and every transaction. Okay? It's not being done. I know it sounds simple. It is simple, but it's boring. That's why I'm not doing development anymore. What do you think? It's boring development, I know. But it's got to be done. So now the interesting attack. I mean, interesting. Everybody wants to steal money. So that's the way you do it now. Is with those right logic flows. Right logic flows is exactly the opposite. We don't read, we write. So write in that sense will be whatever that leaves a trace. So a transaction is a write. When I modify your personal information, whatever I do that leaves a trace, that modifies something, it's going to be a write. Again, applications are stupid. They just do what they are told. So you just told them to perform the fraud for you. And again, supposedly it will check, but it won't. It just never does. And what it does, it never does properly. So we'll still find the flow and we'll still bang on it. So of course, this one everybody has tried, even some of my colleagues who are not specialized into that kind of stuff. This is definitely the prime suspect. When you see something like this, your hands are itchy and you're going to try something like that. Everybody has in the IT security industry. Instead of forwarding a message whereby the money goes from my account to my friend, I will change the from fields to the victim going to my friend, or to a second of my account. So of course this is a prime suspect as far as logic flows are concerned, because that's the very nature of that functionality. What you have to remember with all those logic flows is the more features your bank application has, or any other application for that matter. This is just bank because, well, you steal money, it's nicer. But every other web application are the same, when it comes to logic flows. The more features they have, the more easy it's going to be for us to find one that we can abuse in a way or another. So this one to abuse is very straightforward. Of course, I steal money right away. But here I'm still not stealing from the bank. Imagine, I have to find a poor soul from which I will steal money. Sometimes you want to steal from the bank if you don't like the bank. So another one, cashier order. Again, I have very limited financial knowledge. Until recently, a cashier order I never received any. But we stole lots and lots of money using that on the other hand. By the way, before I continue, don't be scared. When I say we stole and so on, we're totally legal. I don't want the police to storm and everything. This is whatever we've seen when we perform application assessments before they go live. I may have forgotten to say that. So don't worry, don't go out and close your account right away with the bank. Usually they do check. If it's not now, help yourself from the victim funds. Buying share at discounted price, I love that because I don't know how to buy share properly. So I don't know anything how to follow the price and everything. So when you buy it cheaper, you're pretty sure to never lose out, Here we just attack the price number. Some people are a bit smarter than that. They will hardcode because again it's a prime suspect. They will hardcode the price on the server, on server side, so you can't modify it. But in which case you just get them for free. In that case, you just take the money from the victim instead of from your account. If you can't get it cheaper with your money, then never mind. You cheat even more, and you get it free. Again, share for free. I don't mind. Transaction fees. Well, of course, banks charge transaction fees for about everything. You lose a card, whatever you do, you pay and pay. So pay and pay now doesn't really matter anymore because some application lets you choose from which account you want to pay. I mean, You want to pay from your own account A or own account B? No, I want to pay from the victim accounts a lot better. Again, I'm going quick on all this because I want questions later on. But you know already that you cannot ask questions about authentication because I told you your authentication is useless, no matter how good it is. Additional replay mechanism whereby a payment gateway, banks typically never accept credit card payments because they don't want to pay for the fees, the visa fees and all that. So, you know, they know how it works, so they're not going to pay for it, they're not stupid. But on the other hand, sometimes banks, through the internet banking, propose you to buy insurance and all sorts of stuff that is underwritten by another company. They just, so it's the other company basically who take the money, who pay the fee. So here typically we do a payment first. We get a transaction number or an approval code or whatever from the payment gateway, which says that the guy has enough funds and whatnot. And you give this one to the bank, and you purchase whatever is it that you wanted to purchase. When the bank application is not done properly, and again this is rare. Luckily, this is rare because this is extremely stupid. You can replay the transaction number several times, and you know you don't have to pay anymore. You just bypass the first part of the handshake. So eventually you buy a travel insurance once for, I don't know, $15 or something like this, and then you buy a life insurance for the rest of your life and you're not paying for it. Come back. This is extremely rarely found. Again, if it is in my slides, it means we've seen it several times, otherwise I wouldn't bother to put it in the slides. This is one of my favorite because the few other, basically when you steal $1 million, I think the bank will find out relatively quick. I say relatively quick because you don't have any logs. No matter what you think, you don't have it. I've worked on enough application and asked enough times for the logs to know that you don't have it. So I can tell you before you check your own bank, you know. So eventually you will find after a while that you're missing $1 million because the customer from which I would have stolen that money will come and knock at your door and say, hey man, where's my $1 million, you know. On the other hand, one of my favorite is definitely this one, whereby you modify the payee information. So some applications allow you to pre-register your favorite payee. Let's say you pay your electricity bill every month using internet banking. So all you have to do is to put amount and pay, and that's it, and it's done because it's already pre-recorded. So, but of course you can modify the settings on that stuff. So what we do is that instead of modifying our own settings, we'll modify your settings. Of course we intercept, we forward everything, and then if the application is stupid, it will let us change the settings. So now the strategy behind this is that I will change all your payee information, account number basically, so that instead of the money, instead of going to the electricity company or going to the tax department or what, your money will come to my account basically, and you will be the one paying me every month. You know, you will be the one clicking on R200 and pay, R300 and pay. You know, I do it with a bunch of users, sit and wait, and you know, let them pay their bills. And as far as they are concerned, it will still show, you know, inside their thing, it will still show, I paid $200 to the electricity company at that price. It's just the account number will not be the account number of the electricity company, but you won't know. You won't know it's not until you check, you know, because it will still be written the name electricity company down there. How to protect against right logic flows? Well, it's very straightforward. Again, this is exactly the same thing, but you're not doing it, so I insist again. You keep parameters on the server side, just do it. If you do that, list parameter, we can't mess anymore with it. Why do you want us to mess with your application in the first place? You don't want that to happen, you just don't. So keep it on your side. And if you do, pass them in reference again. Verify. You never verify. If you verify that it's authorized, then we won't be able to do all that jazz. Are we clear on that? Because you're not doing it. Okay, we're clear. So it means next time I do such an assessment, I don't find this kind of thing, do I? Internal frauds. We don't have that many frauds in Singapore, of course, because Singaporeans are very respective of the law. They respect the law very much. I guess in Malaysia it's pretty much the same, but in Europe, nobody bloody care. So in Europe, you better pay attention to internal frauds, you know. Some of the applications out there, most of them actually have what we call a backend and a front end. The backend is for the bank to play with, to have all the logs, for the staff to work, basically, credit authorization officer and whatnot, to do their job, to allow you to have your credit, to do a lot of things. And sometimes we are able to run backend command on the front end, which is really interesting if this happens. Unfortunately, what we need to do this is that we need an initial access. So it's either I will poach an ex-employee, or I am an ex-employee myself, or I do an educated guess. Right now, after more than 17 applications, we'll do educated guess. It will just work. They're all the same, So this is very likely. This is going to be fast. But on the other hand, what we need is that we need the backend command to be runnable on the front end, and this is quite unlikely because it means the guys are a bunch of idiots. It means they either misconfigured the thing and they installed the backend component on the front end servers, and in which case it's easy to just remove, or it's a complete design mistake, in which case you just trash away the application. But usually it's just a replay mechanism. Once you know how to run those commands, you just run them. Instead of running them from the back end, you run them on the front end. Just log on as a normal, regular front end user. Bypassing roles, again, the back end has loads of roles, like I'm a credit officer, I'm just a clerk, or I'm a complete administrator. What we need again is an initial admin access so that we know what we're doing. Or we have a good educated guess. Educated guess, again, just works fine. This is very likely, therefore. And we replay again. So this one is just likely to happen. The role bypassing always happen. So far, there's, I think, only one application that wasn't vulnerable to it in 17. So that's a lot of crap in those applications. Authoritative binaries, I don't want to talk about it, so I'll just pass. Masquerading as a customer, this is a little bit tricky for those technical of you out there. That might be fun. Some idiots out there stage 2 stages authentication, or they wanted to do something very fancy, whereby you can log on like you always do, or you can do what they call a sign-in. This is mostly for support. So I log on as administrator. I'm the bank administrator, and I want to check, for example, the user Fabrice has got a problem with his balance. So I will sign in as Fabrice, and I'm already logged on, so that I can look on Fabrice account and check that everything is normal. I can do tech support. The problem with this, that since this is very unlikely, luckily, but the problem with this is that if it's not done properly, basically the two-stage authentication, when we disconnect, what we do is that we log off, but we don't sign off. So we're still on the application, but as far as the system is concerned, there is no more audit trail leading back to us. I mean, we are there, but we're not there as far as the application is concerned. They won't, whatever you log will be, don't know which user, they won't know. So this is when you can start attacking like a crazy and never get caught with it. Nobody likes to get caught. So this is usually unlikely. This is a very unlikely kind of feature. If you have such a feature in your application, you should be really scared. This is not a good idea, it's bad design. So now, this is very important for all the banks out there in the audience. You're getting taken advantage of every single time, and now we're going to talk about why you're getting taken advantage of. You will see it's very trivial. First, there's politics involved, always. I've talked with so many security guys in banks, and basically the bank management always want the application ready for a very unreasonable date. They feel they paid enough already, they paid millions of dollars for hardware and software, they don't want to pay security. The security team is always in between. They cannot one side, cannot the other side, so you can't do much. And of course, nobody like us. I'm gonna cry, nobody like us. Especially us, I mean the third parties. So because the third party, the vendor hate us because we make them look like morons, which most of the time they are. The bank don't like us because the application will be late. If we don't stamp the application, it doesn't go on time. But remember, we don't do it for fun, We don't stamp it, it's for your own safety. A lot of banks don't realize that if we don't want to accept the application to go live, it's because you're crazy to let it go live in the first place. So don't hate us for that. But the vendor, you can hate us if you want, I don't care. It's deserved, you know. When they do mistakes that I've pointed earlier on, they deserve. And of course we're hated by the IT departments because whatever bad stuff is there, they have to fix. So more work for them again. So what you should know before buying, again, this is trivial, but you're not doing it. The application shall have, in fact, security problems. It will. I don't know how to say this, 100%. Don't go and think that it won't have, it will. Because they are complex, they're hard, and again, because programmers have no bloody clue anymore. But the best of the best is that the developers, the vendor will tell you it's normal. It's normal. SQL injection is normal. You know, you of course you talk to our database. That's the whole goal, and you go right. They don't understand. So, and they will tell you it's normal and it's all your fault, or they will tell you, oh yeah, but you know, the bank host was supposed to check and it's not checking. It's not my fault. It's not my fault. Not my fault. That's all you will hear. You know, it's not their fault. So whose fault it is? Certainly not mine. Well, it's mine, but I don't care. I mean, I'm the one testing it. I'm not the one. In the end, I'm not the one running it. It's not me who's going to get the money stolen from my account, you know. I don't open accounts with bank I haven't secured in the past, so, you know, at least I know where my money is, you know. I know pretty much nobody will steal the money in the bank account I'm in now because, well, I secured it myself. At least I trust my own stuff. But wait, that's the best is later on. They'll make you pay for fixes because what they found is normal. What you want is, in fact, an enhancement. And guess what? Enhancement, you got to pay for it. So now a security bug, which is not your fault in the first place. You purchased that software, you know, you paid $1 million for it. And now they tell you that this stuff that we found is normal, and they'll make you pay to fix it. That is extremely lovely, but that's just called take advantage of people, you know. And you laugh, but you're being taken advantage every single time, and they make you pay, and you know, and you just pay. And the best for the last is that they won't fix it. They know, even if you pay them to do it, and that's an enhancement, you know, so you pay more and fix. It's in the contract, but it's not in the contract. No. Yeah, but they do because you're stupid enough to sign that contract. I'm coming to this later. Why you should put in your contract to not get screwed, basically. But right now, in the contract, exactly in the contract, you know, you never say that you don't want that. So, well, you know, it's there. It's a bonus feature, you know. So, but eventually, even if you want to get rid of that bonus feature, and that's an enhancement, and you will pay for it, and they won't fix it properly. First, because they don't know how. We will teach them, you know, we're paid to teach them. If they just ask, we'll teach them, no problem. But they don't ask, they know better. They know better, but yet they're not fixing it properly because that's what they think, that they know better. And of course, because they have to fix it for yesterday, they don't have time to fix it. If you expect the guy to fix a major design flaw in 2 days, it's not going to do it, it's not going to work. Okay, and you've been warned. You really were warned. I'm tired of seeing all the single banks I do projects for getting screwed like this every single time because they don't know what, well, now they know. It will have problem, they will screw you saying that it's normal, you will have to pay, and even if you pay, it's not going to be fixed. Doesn't sound nice, but this is what's happening. It is really happening like this, unfortunately. So now, how do we pay attention to that? It's very simple, you'll say, it's common sense, but you're not doing it again. First, you pay attention to your security staff, your own security staff. It means not me, but the guys that you already pay, you know, those guys that work for you for so long and you never pay attention to those guys. They know better, they know very well already. Security guys in banks know their stuff most of the time, if only you ask them. Implicate them more, you know, you already pay for them, might as well squeeze them. Implicate them when you buy an application, they will tell you right away, this is crap, this is good. Yeah, but that makes a big difference, you know, if you buy a crap application from start, then you know you're going to get crap in the end. Whereas if you buy a good application, in the end you might still get crap, but you know, at least you bought something good. So implicate them in the first place, you know? Eventually, whether you buy a good web application or a bad one, there's going to be the flaws that I'll show you. Because of the statistics. I'll show you the statistics later, you'll see good or bad application, they still have those flaws. So, to correlate with what Anthony was saying earlier, this is how you do it. You put extremely explicit security specification. Now you can't say it's normal anymore. Now you can't screw me. It's inside there, SQL injection. You fix. This is not normal. It's part of the contract. It was written in the contract that if there is any, you will fix it. So now there is one, you fix it faster. But be careful, this list is not exhaustive. This is not exhaustive. You don't quote me on this. I don't want to be responsible for that list. You make your own list. But you just show them who's the customer. You're paying $1 million. They will develop it for you. You'll be the only one for who they develop it anyway, because of the amount of customization and all that. Might as well they do it properly. So put it in the specification. If you don't, they'll say, sorry, not my problem. It wasn't specified, so we need to do enhancements now. Are we clear on that? You're not doing it, but I hope now you will. Role of UAT. The UAT usually in banks are not done properly. They only care about those financial transactions. They check, which is good already. I mean, it would be a pity if the application doesn't transfer money properly in the first place. But if it does, you're still only halfway there, because the other half is, of course, security. Once your application works, you want to make sure nobody can steal money from you. Why don't you get your own security staff to do one first round of application assessment for your bank? Sounds trivial, but you're not doing it. Your security staff sit there and watch us do it, which is, nice, but they could have done their own round earlier on, They need not be as technical as we are, never mind, they will do the basic stuff first. Which, again, for me is good, because like this I don't have to do it, it's been done. It will be less boring for me, But, and it will be very interesting for your security consultant on top of it. They want the butter and the money for the butter, those vendors, So if they want their money, which you should give them, I mean, why not? You need the application. Make sure you don't give it for nothing. First, you negotiate to get the source code. They won't want to give it to you. I tell you first, they will not give it to you. They will insist on their life that this is their IP, intellectual property, and whatnot. I always tell them, how difficult it is to do a transfer from one account to another. Wow, this is extremely hard programming. There's about 10 lines of code to do that. Okay, but on the other hand, what's so hard about those? Why is it $1 million? Why does it take 3 years to develop? It's because of the integration with the bank host. And this, well, I can't steal it. Can I? Every bank have a different integration. So even if I steal their intellectual property and I sell it to somebody else, nobody will want to buy it because, it applies only to that particular company. So to all those vendors out there who don't want to give the source, because intellectual property, I don't care. You cannot imagine how I could care less. If I want a good application, so it's better to caress us in the right direction than in the wrong direction, if you get what I mean. So in any case, if you are a bank, you want the source code, simply because if that vendor dies, you don't have the source for the application anymore and you need to update it and whatnot, you won't be able to. So either you get the source directly or you get it under escrow. This is very important. Make sure the guy is liable for fixing bugs. There is no such thing as no liabilities. It's only an end user license agreement of Microsoft that is like this. The rest is not like that. Microsoft and others. Sorry for the rest. There is all the end user products are not liable. It's not only Microsoft. PDF, all those guys, not liable. I write shit, but I'm not liable. But you still must pay me, otherwise it's pirating, So no, if we pay, you are liable. You are liable for whatever you do. So especially when you sell $1 million, Windows is cheap these days, and although they are not liable, they fix it. Some guys don't. Some guys are not liable, and they look at you and they say, sorry, I'm not fixing it. So those guys are one of those vendors. They're not liable for fixing bugs, they won't. So you make them liable and they will. And the best of the best is usually, we come and do recheck. Once we found problem, we'll have to recheck it to make sure that it's been fixed properly, and then we stamp it. Goes to the monetary authority, and then you're allowed to go live with your bank application. So the problem, like I said, they won't fix it properly because they don't care. They're not paying it. You're paying them for each and every enhancement, For every fix, you pay them. And for every fix, we come back and check if it's been fixed. So they don't care. They anyhow fix. Fix a bit here, fix a bit there. Anyway, the security consultant is an idiot. He won't see. I just encoded the stuff. Yeah, right. We don't see it, We come with a hammer your face, and then you go back. We don't sign until it's fixed. So basically, the bank is in the middle. The bank pay because those guys on the left don't care. So that is stupid. Why would you have to pay more because the guy on the left down there don't care? You force him to pay the second round. You will see. We did this once in a bank. We were tired after the 5th round, after the 5 times testing the same application and still haven't fixed. the bank guy just bang on the table and say to the vendor, okay, next round you pay, right? Is that so? And the guy say, how much is it? Then we tell the price, he say, okay, I'm paying. I tell you, we were expecting another 5 rounds, but after that guy paid for our round of testing, everything was clean. Finally, they fixed it. All of a sudden, it's magic. When you pay for it, things get done. So remember, make sure that the vendor is liable for third-party testing in case of a retest. And you will see, it will be magic. The guy will fix it properly. He'll be so scared to pay and pay and pay, Otherwise, it's unfair. Otherwise, it's always the bank who pay, Don't be a sucker. Just don't be a sucker. Right now, all of you are. All of you. Every single one of you. I mean, banks are there. Don't get me wrong. I'm trying to help with that, dog. I'm trying to teach you. Don't be a sucker. And now I'll show you why I say all this is real. Is because on those 17 last bank applications I've done with my previous team and so on, these are the statistics that we found, and those are real life statistics. Since we make a report with tables and whatnot, it's easy. I mean, it's easy. It's painful, but I did it just to show you that I'm not just lying and throwing numbers just like this. I'll show you numbers to show you just how stupid people are. I mean, developers are. So the percentage of internet banking application from which we stole money, all of them, absolutely all of them, on 17 applications. Application from which we stole personal or financial information, and remember, no matter what country you're in, privacy is safeguarded in every country that I know of. Even if it's not a requirement of your monetary authority, it is still a requirement of your country. 100%. So your application go against the law. If I can take Anthony information, he will sue your bank, you will lose. Whether the monetary authority of Malaysia or Singapore or whatever allow it or not. So you see, all the applications are at least vulnerable to those 2 flaws. 100% of them, out of 17 applications in a row. So I'm not bullshitting, I'm really not. So now the breakdown. The breakdown, as you can see, 26 is mostly the rest. We look horizontally, that's 25% for system information disclosure. This is all the information that we can see when we mess around with your system. We'll find out what web server you're running and all that. This is not a hack, but this make our job way, way, way faster with all those information that we find. Loss of confidentiality, this is when I read your credit card info and whatnot. There's 11% of this, of those flows. Remember, 11% of those flows, but spread on each and every application. Remember, 100% of them are vulnerable to this. Session related, like I said, you spend all your money on the session, making it damn hard and whatnot, and yet we have 11% of those session stuff that are crap. So even if you spend so much money on it, it's still not good, even though it was in the good section in the beginning of my talk. Cross-site scripting is the same, although it should never happen. We have a bit of it, 9%. Stolen money, again, 9%. But again, there is at least one such flow in every application. So it's not because the percentage is low that you're not at risk. You are at risk. It will be there. There won't be many of them per application, in other words, but it will be there. And denial of service and SQL injection. See, so we have 3% of complete morons out there in developers, 3% of SQL injection. Cryptography, very few mistakes because people don't use it. As simple as this. Why should they use it? Because they already don't understand the difference between encoding and encryption. Don't expect them to use encryption. By the way, for developers out there, don't ever write your own encryption algorithm. Just don't. Unless you're a doctor of mathematics from some famous university. Otherwise, just don't. You will shoot yourself in the foot. You will. I might not find it, I'm not good in math, but you'll definitely shoot yourself in the foot. So, out of 17 application assessments, total number of vulnerability found, 275. So, it means we're very busy. I hate writing report, I just hate it like everybody else. But this is what you pay for. So we have to do it properly. And the more vulnerability there is in an application, and the more I hate the vendor for it because my report is bigger. Okay? So please, vendors out there, make your application more secure, make my job a lot easier. Beta quality scripts are all those scripts that don't compile, that spits error messages that are anyhow written. So totally, on a total, we found about 229, which were totally beta crap, in other words. Unnecessary fine, that's even better. These are files that have nothing to do on your server at all, like a zip file, like a photo of your holidays, everything. Now, but we found some stuff like this, and you can see we have 341 files that have nothing to do on your server. I mean, your server is $4 million. I don't want to see no picture of your holidays down there, you know. It's got nothing to do with banking application. But the one that you should be interested in is that per application we end up with an average of 16 vulnerabilities. At least one of them we steal money, and at least one of them we compromise your privacy, remember. Okay, so 16 vulnerabilities per application is not that much. So it means, as you can see with the total number of vulnerabilities, some applications were really crap, more than the rest. Some of them counted like for 200, for just, 100, just one. Of course, it's the one we tested 5 times in a row. The most important of all is definitely the risk of those vulnerabilities. Remember, I said we find 16 vulnerabilities per application in average, depending on the size of your application. And out of those 16, we have 44% of these vulnerabilities that are high risk. They are critical. We steal money from you, that's high risk. You're in the deep shit, in other words.